Hello, I'm Ian Clark, and today I'll be giving an overview of my personal project, Item Value Prediction for Dark and Darker. Here's what we're going to be covering. Introduction to Dark and Darker and the trading challenges, how I capture data with network sniffing, parsing and processing messages using LLMs, data cleaning, feature engineering, and model training, and deploying a web app with custom OCR pipeline. Dark and Darker is an FPS PvPvE game where you enter the dungeon, get loot, and try to escape. In Dark and Darker, items follow a similar format, where there are base stats and random attributes. Base stats are the item's core and are always present for the same item type. Attributes are randomly selected additional modifiers. The usefulness of these properties varies significantly, leading to substantial differences in item value. In Dark and Darker, high-value items are traded through the trading post by exchanging items of comparable value. But currently, if you want to trade an item, you have to wait in the trading post for someone to post an item that is similar to yours to get a price estimate, and if you want an accurate estimate, you have to wait for multiple people to list a similar item so you can average from multiple different sources. The solution is to automate trade post monitoring and use AI to estimate item prices. Simpler methods exist, but this project explores AI as a solution. Now let's get into how I capture data with network sniffing. When you're in the trading post, the game server sends the trade message to the game client over the network. We intercept that with Wireshark and then decode the packet using protobuf. Protobuf is an encoding schema that games use to increase network efficiency. But first we have to extract the proto files in order to decode that data. Then we save to JSON. After running the capture overnight, I was able to get around 56,000 trade messages. Here on the right, you can see the JSON of what that message would look like. You have the chat string that the user listed and the item ID. In order to utilize our data, we have to extract the value the players associate with their items and their messages. Parsing these messages manually requires programming many edge cases and is time consuming. LLMs can extract the value from many formats. Currently, items are traded using common currencies. Currently, DB and LAD, short for Death Bloom and Life After Death, are used. I have decided to experiment with LLMs to extract value information. Here is my prompt, and you can read through it if you like. I have set up llama.cpp with the Llama server using DeepSeek R1 Distilled model. This is a reasoning model, and I am currently in the process of implementing and testing it. To predict the price of an item based on its information, I decided to use a random forest regressor to keep it simple. I used the getDummies command to one-hot encode the name column. After training the model, I noticed that there was a grouping of items over the medium value. This is because it's extremely rare for an item to have super low value and extremely rare for an item to have high value. In the future, my model could account for this. In order for users to interact with my model, I decided to create a custom OCR pipeline. OCR stands for Optical Character Recognition, and it converts image to text. Here you can see this longbow. If we input it into the Tesseract OCR, it outputs the text that is shown on the image. The game's font caused issues with the standard model, so Anders from DarkerDB created a custom model by labeling 100 item screenshots, enabling it to read the text accurately. I then created a web app in order for users to interact with the OCR pipeline. I used Python and Flask to build a simple one that allows users to upload images of their items. The user uploads a screenshot of their item onto the Flask app. The OCR converts it to text and then into features. We input that into the random forest regressor and display the value estimate on a web page. Here's a demo workflow. We have a bloodthirst here. We take a picture of the item using the Windows snipping tool, upload it to the web page, and then fill out all the item attributes and submit to get our price. This project is available on GitHub, and if you have any questions, please feel free to contact me. Thanks for watching.